Jai Hind everyone. My name is Gunjan Saxe. I am working in AKGEC Engineering College, Ghaziabad. I am assistant professor in Department of Computer Science and Engineering. I am taking design and analysis of algorithm for 5th semester students and the subject code is KCS 503. Today I am taking as my topic sorting algorithm. Commonly I am discuss the counting sort algorithm. So let's start. These are the outlines of my lecture. Before starting the working of counting sort with complexity, I have just take a look to introduction to the sorting, after then stability in sorting, different type of sorting, after then counting sort with working and the complexity. So let's start. What is sorting? Actually, sorting is the technique for arranging some random data in increasing or decreasing order, or we can say sorting refers to the arranging a set of data in some logical order. This logical order may be in increasing order or decreasing order. For example, a telephone dictionary can be considered as a list where each record has 3 fields. Number 1, name is there, address is there, and phone number is there. So, being unique, phone number can work as a key to locate any record in the list. So, we can say the sorting is the one of the most important algorithm design techniques. We are given a sequence of item, each associate with a given key value, and the problem is to arrange these particular elements, or we can say items, so that they are in increasing or decreasing order by the key value. So, here there are 2 different type of categories, or we can say methods for sorting. Number 1 is internal sorting and another one is external sorting. As the name suggests, internal sorting algorithms are sorting algorithms that sort the data that can fit into the main memory. We can say no need for any kind of external storage. Example of internal sorting algorithm includes bubble sort, insertion sort, selection sort, quick sort, etc. On the other hand, external sorting algorithms are algorithms that sort data that is too large to fit into the main memory. So, we can say we need external memory like floppy disk, pen drives, etc. And the example for external sorting is external merge sort. Next, this is the property for any kind of algorithm, if it is a stable or it is unstable. Now, what is stable in sorting? If a sorting algorithm, after sorting the contents, does not change the sequence of similar content in which they appear, it is called as stable sort. Let us take an example. Here we are watching, this is the random data. Here this is the 26 at the position of 6 and this 26 at the position 8. So, this is the repeated term and this 6 is previously settled before this 26. This is the sorted arrangement. We can say any technique, after applying any technique, we got this sorted data. So, here I am showing this 26 value, which is at the position of 6, after the sorting comes to the position 3, and this 26 which is at 8th position in the array, after the sorting comes at the position 4. So, we can say here the place value of these similar keys is not changed after the sorting. So, we can say this is the example of stable sort. On the other hand, what is the unstable sorting? If the sorting algorithm, after sorting the contents change the sequence of similar content which they appear. It is called as unstable sorting. As the example is shown, this 26 at the position of 6 and this 26 at the position of 8. After the swapping, or we can say apply the sorting, the sorted result is there, and the 26 which is before this 26 is sorted array after this 26. So the place value of similar key is not same. It is going to be changed. So we can say this is unstable sort. Okay. Next. Here I am giving just a list of different type of sorting like bubble sort, selection sort, insertion sort, merge sort, quick sort, and many more. And I believe in your first year you already taught programming for problem solving as a subject, and you already covered the above 3 algorithms. After then, in your data structures, I believe you already covered like merge sort, quick sort, heap sort, maybe radix sort in little bit. And in your 5th semester, the counting sort arises a very new topic for you guys. That's why today I am taking counting sort as a lecture topic. So let's start this particular topic. Counting sort, or we can say count sort. Then as the name implies is count. In this particular algorithm, we are just making some counts, and with the help of this count, we are going to sort the random data. So here we will discuss the counting sort algorithm. Counting sort is a sorting technique that is based on the key between specific range. This sorting technique does not perform sorting by comparing element. So as the names are here like bubble sort, selection sort, insertion sort, merge sort, all these sorts are doing this sorting on the basis of comparison of 2 elements. After then decide the swapping taking place or not. But in counting sort, there is no kind of comparing any element. So this is not a comparing algorithm. It performs sorting by counting objects having distinct key value in the given array, like hashing technique. So first just a quick view about the counting sort algorithm, or we can say how counting sort actually works. So there are some 5 steps which in particular this slide I am just try to give the overview of these particular steps. After then, by using the code, we are just implement step by step or code by code. So the very first step is, in this particular algorithm, we maintain 2 arrays. One with the size of input element without repetition to store the count value. Just we are counting the elements, how many times the particular element is going to be encountered. And the other with the size of input array to store the output, or we can say just building the output array which is having the sorted data. Step number 2, we have to initialize a count array with all the zeros and keep the output array empty. So we are going to fix zeros in counter array and the output array keep empty. Step number 3, every time an elements occur in the input list, increment the corresponding counter value by 1 until it reach the end of the input list. So in this particular step, we are just maintaining the counting array, and when this particular step is to be completed, the counted array is done by the number of count of particular elements in the given array. Now the step 4. In this particular step, the output array, every time a counter is greater than 0, add the element at its respective index. That is, if counter of 0 is 2, to add it to the second position, that is first index of the output array. Then decrement to the counter value by the 1. Step number 5, repeat step 4 until all the counter values become 0. The list obtain the output list. So, for considering these particular algorithm, now I am taking the example. Suppose this is the random data, right? Here, this is the index and this is the data. So, the algorithm first step is just find the maximum range. What is range? These are the distinct values, and in this value, as we see, 6 is the maximum key value. So, here K is 6. What is K over here? K is the distinct maximum value. So, the step number 2, initialize an array of length max plus 1. This is the specific range 6, and we are going to create a count array. The index of these particular array is starting from 0 and up to the 6. As I already said, the length of this array is max plus 1. Now, we initialize all the place value of this particular count is 0. Okay. This array is used to store the count of the element in the array. So, what we are going next? The step 3, store the count of each element at their respective index in the count array. So, this is the final counted array. Now, one by one, I will discuss how this count array is to be implemented. So, this is the count array at the basic position when all the keys are filled to be 0. This is the actual code. By using this code, we are getting to know how we are getting this particular array. So, here as we see, the value of I is 0, right? Which is 0 less than 9. What is 9? The number of elements, which is 9. So, 0 is less than 9. Condition is true. So, we are come to this particular loop. Now, what is the solution of this particular code? Here, A of I, and the value of I is what? 0. A of 0. And what is A of 0? Which is 1. And after then, what is 1? Actually, this is count of 1. And what is count of 1? As showing here, this is 0. After then, we are going to increment in this particular count. So, plus plus count 1 means the value at count of 1, which is 0, we are going to increase that particular value. Now, by iterating one step of this loop, we have this kind of updation. Now, as we know, modification is be there. So, I becomes 1 and 1 less than 9, condition is true, and A of I. So, we can say A of 1. A of 1 is what? A of 1 is 3. Then, in count, just writing C in place of count. So, C of 3. What is C of 3? It is 0. Now, just increment by 1. So, in place of 0, now the updated value is 1. Again, modification, I equals to 2. Again, 2 is less than 9. condition is satisfying, and this particular code give us A of 2, which is 2, and count of 2, which is 0, and we are going to increment by 1. Now updated by 1. So I believe you can understand how this code is working, right? This code is going to be executed for I equals to 3, I equals to 4, I equals to 5, I equals to 6, up to I is less than and equal to 9, or we can say it is going to 8 less than 9 till this condition. After moving these loop by these kind of iteration, we got this counter array value. So this counter array actually giving the exact count of these particular distinct value in the given array. I hope you can understand how this particular count array is created. Next. So the step number 4 is just update this array. Why we are updating? Actually, we just know the place value in the sorted array, and this is the actual count value of the distinct element, and we know how we are going to this particular one at which position. How we can know? So we are going to just update this count. We no need to make another array. We are just counting, we are just updating the count array as well by using this particular code. Actually, this is the cumulative sum. What is that? The first value is as it is, right? And the next value will be the sum of the actual place and the and the last value. So just I am showing by the example what is the value of next is 0 plus 2, which is 2. What is that particular value? 2 plus 1, which is 3. And so on. 3 plus 3, 6. 6 plus 2, 8. 8 plus 0, 8. 8 plus 1 is 9. Now, how we are going to implement this, or we can say what is the working of this particular work. So I am taking another loop which is going to 1 to k. Why 1? Why not I am taking 0? As I already said, the first position as remains same. So हमें not to apply the commutative sum at this place, right? So let's consider this particular code. The value of I is equals to 1, right? We are checking I less than or equal to k. I is 1 less than or equal to k, which is 6. So we can say the condition is true, right? So coming to the loop, what is the working of this particular statement? Here, count of I. Count of I means C of 1 is equals to C of 1 plus count I minus 1, 1 minus 1, which is 0. So just checking C of 1. This is the our count array. C of 1, the value is 2, plus C of 0, the value is 0. So C of 1 is 2. Okay. Again, increment in I becomes 2. and 2 is less than and equal to k. Okay, condition is true because the value of k is 6. Again, I am entering in loop and the same process encountered. What will that? Count I, which is count 2 equals to count I, that is C2, and count I minus 1, that means 2 minus 1, which is 1. And C of 2 is 1 plus C of 1 is 2, which is 3, and here will be 3. So I believe as I am doing these steps, you can do it by self until the condition is going to be false. So we are doing these particular statement or implementation up to I equals to 3, I equals to 4, 5, 6. When the value of I 6, these particular updated count is generated. After then, when we are incrementing in I, the value of I is 7, which make the loop false. Next. After then, this is the very important and the last step, building the output array. So, this is the array B, which I am taking for considering or arranging the output data, and this is the our given data, which is our array A. This is the updated count as we calculate earlier, or we can say just back to this slide. Actually, this updated array is having the count value, not the specific index value, right? We are building the output array. How? Just scan the array from right to left. Why I am going to right to left? I will tell you later. I am just showing because of maintaining the stability property. I am just clearing this thing by the doing example. Okay. So when we are scanning this output, this input array from the right to left, the very first element, as we are seeing, this is 3. So 3 is there. Now we have to find the actual place value in this particular B array. How we are getting this? 3 is there, just go to the index 3 in updated count array, which is 6. So first we have to decrement this 6. 6 minus 1 now becomes to 5. Because why I am decreasing this value by 1? Because this is the count value, not as the index value, and I have to get the index where this particular 3 is to be placed. So put this 3 key at the 5th position of the output array. That's why I am putting this particular 3 key at 5th position. Okay. Now, how this will actually generated? This is the code for generating the place for these particular keys. Let's start. Here I start from n minus 1. What is the value of n? N is 9. 9 elements are there. So n minus 1 is 8. Right? Now I am checking the condition. 8 is greater than and equal to 0, which is true. Now come into the loop. Here what is assigning? This is the value of A of I. A of 8, which is 3. This is the matter. Actually, what is the place of this particular 3 in the output array, or we can say B array. By using this calculation, I am getting the correct place value of this particular 3. How? A of 3, which is 8. As I am saying, A of I, A of I, that means A of 8, which is 3. And whose 3? Counts 3. Counts 3. What is the counts 3? Just I am indexing this. 6. What is the count 3? This is 6, right? This is 6. We are going to decrement this 6. After this decrement, the value of this 3 becomes 5, right? So, in B, that means this is 5. So, we can say this particular key 3 is to be assigned at the place of 5th position in B array. I hope you can understand the final concept of this particular counting sort. Okay, we are doing the same for next step. Again, modifier is there. The value of I is going to be decreased, and now the value is A equals to 7. I'm just going to check this condition, which is true. 7 is greater than or equal to 0. Condition is true. So obviously we are coming to the in the loop, and the statement is to be executed. What is that? A of I, that means A of 7, and the value of A of 7, now as we are seeing, the counter is now at that position, A of 7, and that our value is 4. I am discussing 4 value. What is the actual place of 4 in this particular B array, right? So just calculate. A of I means A of 7, which is 4, and 4, where 4? Count. Count. This is the actual count after the updating this field, and which is say counter 4, and the counter 4 is 8. Counter 4 is 8, and what we are going to do? Decrement in this particular value. Then we have to decrement this value by 1. After then the value becomes 7. So 7, whose 7? The place value of B array, which is the output array. So we can say the key 4 has to be put at the place 7 in the output array. Okay, so just put this 4 at B7, right? Now again decrementing in this particular space, I equals to 6 after the decrement in I, right? So 6 is greater than and equal to, which is true, right? So A of 6, which is now the value 6, right? So A of 6, which is 6, what is the value of this particular 6 in B array? Let's calculate. Here A of I means A of 6. A of 6 is 6 in count. C of 6, what is C of 6? Which is 9, and decrement in this 9, make 8 in B. So we can say the value of 6 at going to be placed at 8, right? So, are you just seeing one thing? As we are saying, we are scanning this particular array right to left to maintain the stability property. So, see, this is the 4 at the position 7, right? Just me update. Here we are putting 6, right? So, I am telling this is the 4 which is at the place of 7, and after the sorting, the place of this particular 4 is 7, and as we know, when we are moving and reaching this particular 4, obviously this 4 is at the previous position. So, the arranging or the place value is preserving after the sorting. So, that is why I am calling the counting sort is maintaining the stability property. So, I believe by using these particular step and decrement up to 6 to up to greater than and equal to 0, you can fill out this particular array. So, I suggest after doing these steps, please comment in the below link. I will be happy. So, next, at the last, by using the same step, we got these particular array, which is the final array or sorted array. Now, the next thing is, what is complexity? How we are going to calculate this particular complexity? In this working model, we are using one loop. We know this loop is going to be run 0 to n. So, we can say the complexity of this particular loop will be n, right? There is another loop which is running from 1 to k, and we can say the complexity of this particular loop is k. One is n, one is k. After then, there is another loop which is going to n minus 1 to 0. So, we can say this is again running n times, then 2n plus k, and after then we have to move this particular sorted array to the actual array. So, I believe you know this concept. By using a loop, we are just copying the data of B to A, another loop, and I believe you can understand this loop again to be run n time. So, total time complexity is n plus n plus n plus k, which is 3n plus k. So, as we know, this is the constant, just ignorable. Then the time complexity of counting sort is n plus 1, order of n plus k. Okay. So, here some points which are little bit negative in terms of counting sort. What are that? Firstly, counting sort does not work on decimal values, or we can say floating points keys, right? Counting sort is an inefficient if the range of value to be stored in very large. Suppose we have an array where the elements are 100 and range is going to 1000 or more. So, we have 100 elements and range is 1000. Then consider how many zeros are there. So, if the range is very exceed, then counting sort is actually inefficient. Okay. And counting sort is not an in-place algorithm because it uses extra space for sorting the array element. So, I hope you learning more by this particular video. In my next video, I will be coming from the next or further interesting topic. Okay, thank you very much.